again. This module is going to be over radiation incidence and response. This is the longest module, so please just bear with me. I'll try to move quickly and try not to bore you by reading off the slides and saying every word. With that being said, let's go ahead and get started. As most of you know, in Hamilton County, we have several sources of ionizing radiation. For example, medical and veterinary clinics use radiation for X-rays, irradiators, and radiotherapy. Many research facilities, such as universities and industrial companies, may possess radioactivity and different types of radioactive materials. One source of radiation people may forget about is transportation. Hamilton County has several major transportation systems running through it, such as the highways and railways. At any time, radioactive material could be transported through our county. If one of these transportation vehicles is wrecked, we could have a radiation emergency on our hands. And as most of you know, we have two nuclear facilities in our area. We have Sequoia, which is here in Hamilton County, and Watts Bar, which is in Bradley County. So the most likely radiological event that we could have here in Hamilton County would be a transportation or facility event. Every year, around 500 billion packages are shipped in the United States. 400 million of those are hazardous, and of those, about 3 million are radioactive. The Department of Energy alone transports about 20,000 radioactive shipments per year. Because of the sheer number of shipments, a transportation incident is most likely to occur. But despite this, there have been no serious nuclear radiation exposures as a result of a transportation accident. This is in part due to the strict requirements of radioactive packaging. Besides transportation risk, we also have several facilities in our county that hold radioactive materials. These kinds of facilities are required to meet the federal standards for storage, use, and security of any radioactive materials. And though most of them are good about meeting these standards, there are several that choose to ignore these requirements, which can lead to the materials being stored and secured incorrectly. This can cause an issue for anyone who may be responding to an incident at any of those kinds of facilities. Vehicles transporting radiological materials in any facility that houses radioactive materials are required to have some kind of marking or placard. These markings may not always be on the outside of the vehicle or building, but instead may be on the individual housing of the radioactive material. Most placards and signs will either say radioactive or have that tri-blade universal symbol for radioactivity. When you are responding to any type of incident, it is important to look for those markings so that you know what kinds of risk you may be facing. Many radiological placards and markings can provide you with some useful information. Being able to interpret this information can help you when you are responding. So for example, each Roman numeral represents a radioactive class. On the contents line, you will see the type of radioactive material. The activity line will let you know the amount of radioactivity, and the transportation index will tell you the acceptable radiation level outside of any unbroken box at 1 meter away. The white 1 label is used for packages with a maximum dose rate of 0.5 millirems per hour on the outside of the package. This measurement is taken on contact with the package. The yellow 2 label is based on the package with a maximum dose of 50 millirems per hour, and the yellow 3 label has a maximum of 200 millirems per hour. So there are several different kinds of packaging that radioactive materials can be stored in and shipped in. There are several examples shown on the screen right here. But on the next slide, I'm going to have a video for you that will explain the different types of packaging in more detail.
When responding to an incident involving radioactive materials, knowledge of packaging will help you to identify potential risks. Selection of a package depends primarily on the level of radioactivity in the materials designated for shipment. The basic idea is, As the level of radioactivity increases, the level of risk increases, so the stronger the package must be. The first types of radioactive materials packages are accepted packaging and industrial packaging. Accepted packages are used to ship very low levels of radioactive materials. Industrial packages are used to ship things such as radioactive waste. Both of these package types will contain non-life endangering amounts of radioactive material. A step up and more secure type of packaging is Type A packaging. Type A packages are used to transport non-life endangering amounts of radioactive material. Typical Type A packages are boxes or drums made from wood, plastic, fiberboard, or steel. Type A packages are identified as such by markings on the exterior of the package. Typically, Type A packages have an inner container and an outer package. Pictured is an empty inner container of a Type A package used to transport medical isotopes. Type A packages can contain a wide range of radioactive materials. Most radiopharmaceuticals used in medicine are shipped in Type A packages. Type A packaging must be able to withstand a series of tests that simulate normal transport conditions. These tests include a water spray test to simulate a rainfall of 2 inches per hour for 1 hour, a 4-foot free fall drop test onto a flat, hard surface, a stacking test simulating a compressive load of at least 5 times the weight of the package, and a penetration test using a 13-pound steel bar dropped from a distance of 3.3 feet onto the package. Type A packages are not designed to withstand accident conditions because the contents are limited so that if the material is released in an accident, it would not present a substantial health or environmental risk. A major step up from the Type A package is the Type B package. Type B packages are the strongest and most specially designed type of packaging. These are often referred to as shipping casks. Examples of materials that are transported in Type B packages include cobalt-60 teletherapy units used for treating cancer, cesium-137 capsules used to sterilize medical equipment, radiography sources used for non-destructive testing, and spent fuel from nuclear power generating facilities. In addition to the requirements for the Type A packaging, Type B packages must be able to withstand transport accident conditions without losing the package contents. These packages will be clearly marked as Type B packages. To simulate accident conditions, federal regulations require that each package must be able to survive various test conditions. These tests are designed to create damage exceeding the vast majority of potential transportation accidents. They include assessing the effects of impact on the package by dropping a package from 30 feet onto an unyielding surface. The unyielding surface used in these tests consists of a 2 million pound, 25-foot deep, steel reinforced concrete block covered with an 8-inch thick steel armor plate. Next, the package must be subjected to a puncture test, where the package is dropped 40 inches onto a 6-inch diameter steel rod, striking the most vulnerable spot on the package. The drop and puncture tests conducted here created very obvious damage to the exterior skin and foam of the package. However, the inner and outer containment vessels remained undamaged. Next, the package must be subjected to a fire of 1,475 degrees Fahrenheit for at least 30 minutes. The burn test conducted here used approximately 8,000 gallons of jet fuel. Finally, the package must be able to withstand submersion under 50 feet of water for at least 8 hours. Beyond these required tests, casks have also been subjected to a variety of other severe accident conditions. For example, casks have been dropped from 2,000 feet onto hard-pan desert soil in order to evaluate the effect of different targets and impact velocities. The underlying idea behind radioactive material packaging is that since transport accidents are possible, one of the most important ways to protect the public and the environment is to require a very high level of package design and construction. based on a study of all radioactive material shipments. The Nuclear Regulatory Commission has concluded that present regulations are adequate to protect the public from unreasonable risk during the transportation of radioactive materials.
Switching gears a little bit, you may be interested in knowing what your role and responsibilities may be if you are responding to a transportation or facility incident involving radioactive material. Of course, the main thing you will need to do is your firefighter duties. The next thing you should know is that you're going to begin helping any injured people. Remember that any unbroken packages never exceed a surface radiation level of 1,000 millirem per hour, so many packages won't pose an immediate risk. You will also need to notify dispatch that there is a radiological emergency going on. Once you have done these things, begin to secure the scene in order to protect the public and the emergency responders. So this slide is just a reiteration of the last. If you are the first on the scene, make sure you're following all of the proper procedures to ensure the safety of the public and the first responders. For scene control, you will want to set up a hot, warm, and cold zone. The hot zone, which is the contaminated zone, will initially be 75 feet until determined that it needs to be larger or smaller based on the materials present. In the warm zone, the decon line will be set up, and in the cold zone, which is going to be that clean zone, make sure that all personnel and equipment not required in the hot zone are positioned here in order to keep them from becoming contaminated. So moving on to a nuclear power plant incident, and specifically for us, an incident at the Sequoia nuclear plant. So if you are responding to an incident at Sequoia, you will report directly to the security checkpoint at the Sally port. Here, security will log you in and issue emergency badges and dosimeters to each person. If there's a major incident occurring and the whole place is burning down, security will still go through this process. So just be patient and follow their instructions. It is also important to note that only official vehicles will be allowed to enter the area. If someone tries to show up in a personal vehicle, they will not be allowed in at all. So once everyone has been checked in, you will be escorted into the facility, and then initially only one engine at a time will be allowed through security. Once they have got one engine in, then they will continue to check in each engine at a time. So others are going to go ahead and stage at the staging area until they are requested to come in. While you're responding to an event at Sequoia, you may hear some sirens going off and an announcement stating for all non-essential personnel to evacuate. You, unfortunately, will be considered essential personnel, so just ignore the alarms and continue on. Many areas of the plant can be contaminated, so if you see signs stating so, do not enter those areas unless you have been given authorization. As we will discuss in the PPE module, your turnout gear and SCBA will offer enough protection to be going into those contaminated areas. Though this is true, you will need to remember not to eat, drink, chew, or smoke while in the contaminated area, as you may run the risk of becoming internally contaminated. You will also need to make sure that you and your equipment are monitored for contamination when leaving the contaminated area. While on Sequoia's property, TVA's fire brigade will assume command. So make sure you are following their instructions. Also, remember that when you are talking on the radio, try not to use words such as contamination and radiation unless absolutely necessary. So this image here shows the different areas that are located on the plant's property. The protected area vehicle entry is where you will enter if you are responding to an event. This is where that Sally port is. It is also good to remember that the contaminated buildings and spent fuel storage will have the main sources of radiation, so if you're working in those areas, try to use as much caution as possible. For this slide, I have a video that will explain how the nuclear plant works. Keep in mind that the plant described in the video is the same as the one here at Sequoia.
Nuclear power plants are thermal power stations which generate electrical energy from heat. They consist of numerous buildings and facilities, the most important of which are as follows. The turbine building houses several turbines as well as the generator necessary for electrical power generation. The containment building where the nuclear reactor is housed is made of meter-thick reinforced concrete. Inside this building, nuclear reactions take place where water is heated up. The cooling tower, which can be as tall as 200 meters, is where hot water is cooled. In order to easily understand the underlying principles, the following is a description of the most important components of a nuclear power plant that uses a pressurized water reactor, PWR. In the reactor pressure vessel, the nuclear reaction and the associated release of thermal energy takes place. In a pressurized water reactor, as in this case, the reactor pressure vessel stands about 12 meters tall. The walls are about 25 centimeters thick. Inside is where the fuel assemblies can be found. In pressurized water reactors, about 150 such assemblies are installed. A single fuel assembly is composed of many fuel rods. A fuel rod is about 5 meters in length and has a diameter of about 23 centimeters. The actual nuclear fuel is found inside of each fuel rod. Small nuclear fuel pellets composed of enriched uranium or plutonium make nuclear fission chain reaction possible. In the fission chain reaction, thermal energy is released. Water is needed in order to absorb the thermal energy and keep the chain reaction going. Inside the vessel, the water is heated to over 570 degrees Fahrenheit. The water does not boil, however, since the pressurizer maintains the water pressure constant at around 160 bars. The heated water is eventually pumped to a heat exchanger, also called steam generator. These are typically in the form of a shell and tube heat exchanger. Hot water flows through the U-tubes, heating up the metal of the pipes so that any water inside the heat exchanger begins to boil. The resulting steam is eventually fed through a set of pipes to the turbine building. The steam first drives a high-pressure turbine and then is typically fed to 2 low-pressure turbines. All of the turbines are connected by a spinning shaft to the electrical generator, which in turn produces AC electricity from the shaft's rotational energy. The steam is converted again into liquid form in a condenser, and then returned back to the steam generator. The water needed for this often comes from an adjacent river, or is cooled in a cooling tower. The water circulation systems are always kept separate from one another. Water in the primary circulation system never leaves the containment building. This water is radioactive, since it has been in direct contact with the fuel rods. Water in the secondary circulation system is used to drive the turbines and is not radioactive. The cooling circulation system provides cool water and is used to condense the steam in the secondary circulation system.
As the video just discussed, there are several safety and containment measures in place at Sequoia. The first two layers are the fuel and cladding. These are designed to contain all of the radioactive material inside the reactor core. The next is the reactor vessel. It is designed to hold a coolant that is used to move heat created by the generating electricity. The final two barriers are the containment building, which is designed to mitigate the release of radioactive materials in the event that the other barriers do fail. Along with the containment measures, there are several emergency cooling systems in place. These systems cool the reactor if the coolant in the reactor is lost. The first system is the controlled rods. These can be removed from the core to decrease radioactivity. Next is borated water injection. This is when a large amount of cold water is dumped into the reactor core to cool and minimize fuel damage. And then we have the ice condensers. This method allows steam to be absorbed in order to reduce containment pressure. And the last system is river water. If all else fails, river water can be pumped into the reactor vessel through 5 60-inch intake pumps. So what happens if all of these barriers fail? Well, first of all, this is very unlikely, but if it did happen, there could be an accidental release of high levels of radiation, often referred to as a plume. This plume can be dangerous because as a plume spreads across an area, the radioactive material can settle and contaminate anything and everything that is outside, along with buildings, food, water, and livestock. As we discussed in the radiation basics module, there are 3 types of radiation that can be released from a nuclear plant. These are alpha, beta, and gamma. Alpha is the least penetrating and can easily be blocked by a piece of paper or even by your skin. And since it's the largest particle, it can only travel a short distance. The main hazard associated with alpha is internal contamination. For beta radiation, it can be blocked by a plastic and can travel only a few feet in the air. Like alpha, it also can be an internal hazard and can cause harm to your skin and eyes. The third is gamma. Gamma can only be shielded by thick, dense material such as lead or concrete. Since it will pass right through your body, you are at highest risk of whole body dose. Moving on to an incident at the nuclear power plant. So if all of the safety features fail, a radioactive plume could cause problems for Hamilton County. To begin with, all of Hamilton County falls within the 50-mile ingestion exposure pathway, and a majority falls within that 10-mile emergency planning zone, or EPZ. Also, a good part of our county falls within the Watts-Bar 50-mile ingestion pathway. Within the 10-mile EPZ, there is a risk of whole body exposure through gamma radiation, thyroid exposure through inhalation, and exposure to critical organs through inhalation. For the 50-mile ingestion pathway, food and water can become contaminated, which could result in the increase of radiation-induced cancer. At the Sequoia plant, we had divided the emergency planning zone into 23 sectors. Within those 10 miles, there are over 93,000 people, 25 schools, 22 daycares, 15 assisted living centers, and over 150 individuals with functional needs. Within that 50-mile ingestion pathway radius, we have over 1 million people. If there is a nuclear event at Sequoia, these are going to be our top priorities for protecting the public. We want to make sure that everyone is sheltering in place or that we are evacuating vulnerable populations such as children and those with functional needs. We're also going to shelter in place or help evacuate the general public. And then prioritizing security for evacuated areas and routes, shelters, and staging and recovery sites. We will prioritize the monitoring and decontamination of all emergency workers and the public, as well as provide radioactive protective drugs such as Ki. So there are several ways the public can be notified if there is an event at the nuclear plant. These notification systems can be activated through the state SEOC or county 911. These systems include fixed siren system, which are the sirens spaced out around that 10-mile EPZ, the emergency alert system, tone alert radios, and emergency responders going door to door informing people of the situation. During a radiological emergency, the public may be told to do one of two things. First is shelter in place. This order is usually given upon release or imminent release of radiation. The second is evacuate. If required, the public will evacuate any area that has been or will be affected by the release of radiation. If it is safe to do so, schools, daycares, and assisted living facilities will also evacuate. Here are some things you should keep in mind when an evacuation is in place. Remember that most people will evacuate prior to an official notice. Word is going to spread quickly if something does start to happen at that plant. So many people will begin to evacuate before an official order is actually sent out. This will also happen at the schools. Parents will begin finding out that something's happening and begin picking up their children before the evacuation may begin. A high percentage of people will stay with family or friends and will not actually stay at a shelter. Some individuals with functional needs or without transportation will require evacuation assistance. Also, some residents will resist evacuation. In situations like these, it's unlike a natural disaster such as a hurricane where people can choose to not follow an evacuation order. But for a radiological event, people must evacuate their homes. Because they may pose a risk to themselves or other people if they become contaminated, they have to be forced to leave. When an evacuation order is issued, evacuees will need to evacuate using pre-established evacuation routes. Security will be set up along these routes to ensure safe and effective evacuation. Moving on to shelters. So there are 11 shelters within the 4 counties designated for a Sequoia emergency. As I mentioned a few slides back, there will only be a small portion of people who will actually stay at a shelter. We have planned for sheltering up to 20% of our population. All the shelters are going to be in place will be managed by the American Red Cross, and the Hamilton County Health Department will be conducting the public monitoring and decontamination processes. As I said before, we have 11 shelters spread out between 4 different counties. All shelters will either be in Hamilton, Meigs, Ray, or Sequatchie County. Another kind of site that will be set up during an evacuation is the shelter information points. We have currently pre-designated 8 sites around the county where people can go to obtain additional information on evacuation routes and shelter locations. First responders can also go to these sites to get monitored for any contamination. When there's an event at the nuclear plant, TVA will notify TEMA and then notify local department leads, such as the Director of Hamilton County Office of Emergency Management. At this time, the Sequoia or Watts Bar plan will become activated. Each department lead will activate their department as outlined in that plan. Each plant has 4 levels of emergency classification. These are notification of unusual event, alert, site area emergency, and general emergency. At each classification level, each agency's response is different. If you want to see your agency's responsibilities, you can go look at the Hamilton County Multi-Jurisdictional Radiological Emergency Response Plan. Okay, so most of the information on this slide was gone over earlier in the module, so I'm just going to go over it again quickly. If there is an incident at the plant, you will be responsible for assisting with evacuations and making sure areas are completely evacuated, along with any monitoring that may be needed. In addition, you will always be responsible for protecting the public and emergency responders, including any rescue and contamination control. Once the event is over, people in evacuated areas can return home as soon as conditions permit. These areas must be checked and decontaminated, which can take a significant amount of time. When the initial response is over, recovery efforts will begin once the problem at the plant has been resolved and the evacuated areas are deemed safe for habitation. These efforts will be initiated by the state governor at the recommendation of the director of TEMA, commissioner of environmental and conservation, and TVA officials. So moving on to different kinds of nuclear threats. Hamilton County's response to any nuclear threat will be similar to a response to a nuclear plant. Our response is outlined on this slide. So a nuclear weapon uses a nuclear reaction to create an explosion. These explosions give off 4 types of energy. These are a blast wave, intense light, heat, and radiation. When the explosion happens, a large fireball is created, and everything within that fireball vaporizes and creates a mushroom cloud shape that we are all familiar with. When everything in that cloud falls back to the Earth, it is called fallout. The fallout is radioactive and contaminates everything that it touches. Another type of nuclear weapon is a dirty bomb. A dirty bomb is a mixture of different explosives mixed with radioactive materials. The biggest threat with the dirty bomb is the explosion, not necessarily the radiation, due to the small amounts of radiation that a dirty bomb can actually contain. When the bomb explodes, it can send shrapnel through the air, causing serious injury and property damage. Next is a radioactive exposure device. These devices can contain radioactive material that can expose people over a period of time without their knowledge. This can be hidden in public places like buses or busy hallways where people often pass by them and never know that they're being exposed. If a nuclear weapon were to detonate in our area, you are going to assume the shelter-in-place guidelines. These are get inside, and stay tuned. Do not leave your house until specifically told to do so. If you do leave your house, take as many precautions as possible and make sure you are wearing any proper PPE. And that concludes our very long module on radiation incidents and response. If you have any questions, you can always contact me at the number on the screen.